Okay, I think I all can see my screen, right? Okay, so till now we have discussed probability, of course, and then the some discrete distributions, and then obviously some problems related to discrete distributions. So now we will start with this continuous distribution, and then we will solve some questions from the continuous distribution, and then we'll move to the other part of the syllabus. So the one thing is there, after the this probability part, we'll move to the discrete maths, and maybe hopefully we'll complete the discrete maths and all the topics in this week only. And after that, we are having just mathematics person. So I don't know whether I will able to provide the lectures slide lecture for the mathematics or not, because there are a lot of mathematics topic that we need to study. And but I will just try to do those important topics like matrices and other things. Maybe permutation combination will cover discrete maths only, and some other portion like function and something like that, APGP. So we'll just cover a short introduction to those so that you can solve the questions. Obviously, we can't go into in depth solving 50 and hundreds of questions. Okay, no problem. Just we'll see like what is going to there. Okay, so like in the continuous distribution, actually we actually start with this particularly rectangular distribution, or called uniform distribution. So uniform distribution X is said to a random variable X is said to have a continuous distribution over an interval AB if its PDF is constant over entire range. So any rectangular or uniform distribution is a constant PDF. So like let's say we are talking about any particular range A to B, and it in particular that the particular thing will be the constant. There may be any C or maybe any K. Okay. So this particular PDF, if you encounter somewhere, this is the example of rectangular and form distribution. But the thing is that K should be a number, like it can't be a symbol only, like a K is a symbol, or maybe C, or maybe alpha. So how means according to this property, like if it's going to be a constant, like what is the constant there? Okay, so we know that if we have any continuous distribution or theoretical distribution, if we just either integrate, obviously for the continuous we integrate, and for the theoretical distribution we sum. If we just integrate over all the continuous interval, we will get the value of 1. So obviously if you just do this particular thing over the given range, we will just get this particular thing. Obviously this particular thing is x, and this is interval b to a, and then we get that k is equal to 1 by b minus a. So it means that any rectangular uniform distribution will be of this particular kind. Kfx is equal to 1 by b minus a, where x is between a and b. So let's say it's x is between alpha and beta. Obviously it will be 1 by alpha, beta minus alpha. Okay, this fx is. So this particular thing will be there anywhere you can encounter a this uniform distribution. And like why this particular distribution is called rectangular distribution, why is that? Because when you plot this particular graph, like from a to b, so from a you can see that key a here is and from b the entire distribution is defined to be this particular number. Okay, this 1 by b minus a. So that's why this particular thing is called as rectangular distribution, because obviously at point A we have this particular thing, and over the whole given limit we have the same definition of distribution. So when you plot this thing, you will just see the rectangle. That's why it's called a rectangular distribution. So obviously like these distributions can be of different types. Let's say we are talking about x between minus a to a. Okay, so x we are contributing minus a to a. So in that particular thing, this particular distributions will be what? It will be 1 by b minus a, means 1 by a minus a. So it will be 1 by 2a. So if you see something like this, also an interval is given this, it is also example of continuous distribution. Okay, continuous uniform distribution. It may be sometimes like like let's say b a is equal to 0, and b is equal to a is equal to 0, and b is equal to sometimes only 10. In that particular case it will be just 1 by 10, and your this distribution will be a 0 is equal to the next less than 10. So this distribution can form any of these given format, and the thing is that it will be just have this particular range, and it will be constant over the entire range. So this particular thing is called uniform distribution. Okay, so like when you just go to the way like we calculate the expectation or mean of this particular distribution, which is a to b x dx. Okay, so this particular thing y b minus a. So this particular thing, if you just do it and calculate, you will get that this particular mean is going to be a plus b by 2, and the variance is going to be b minus a ka whole square upon 12. Okay, so this particular mean and variance is of uniform distribution, and the moment genetic function is e to the power bt minus e to the power at upon t b minus a. Just it's look like a simple distribution, but moment genetic function is actually some power of exponential or something like that. But obviously this thing is being taught ki if you just find somewhere that ki any a moment genetic function is given and not a distribution is given, and you find it in a particular moment genetic function of this type, then at that particular point you can simply say that okay, this is a uniform distribution where whatever this b number is, it will be the b, and whatever the a number is, it will be the a, and this will be the definition of this particular distribution. Okay, so just let's see like how we can do some problem based on the simple distribution. So let's say if x is a uniform distribution with mean 1 and variance 4 by 3. Okay, so this particular thing is given, mean is given 1 and variance is given 4 by 3, and then we have to find probability of x less than 0. So it's given that it's a uniform distribution, so we will have something like that. Okay, so like uniform distribution is represented by this particular thing u, and then the first parameter and the b, the second parameter. So a, b are the parameters of the distribution. Okay, so we know that this particular thing is a uniform distribution because it is given, but we don't know this particular thing whether it's going to be a, what is the a and what is b. So for that we will find that particular thing using the mean and variance. Okay, so we know that x is this particular thing and x distribution of x is going to be this particular thing. Okay, this particular thing is given to us. Now mean is 1, so a plus b by 2 is equal to 1, and b minus a squared upon 12 is equal to 4 by 3, because this is a variance formula. So if you solve it, you will get that a plus b is equal to 2 for this, and b minus a square is equal to 16 for this, and we solve this particular part to get b minus a is equal to plus minus 4. Obviously, if you solve this thing, you get b3 a minus, and if you solve this particular equation taking minus 4, you will get b minus 1 a3. So which one should we take? Okay, so anything you can take, but thing is that like if you just assume this particular distribution, we can see here that okay, we have assumed that a should be means less than b. So means we'll choose only those point which is where b is the greater than a. So we'll choose this point. Obviously, you can see that both are the same thing. Obviously, a cannot be greater than b because this particular format we have chosen. But obviously, if we choose a is equal to minus 1 and b is equal to 3, we get the same particular thing. So both is the same thing. So we now have the a value of a and b. So we know that this particular thing is going to be a continuous uniform distribution, and the format is 1 by b minus a. We just put b, which is 3, and put minus a, so which is minus minus 1, which is equal to 1 by 4. So this particular thing is your uh, uniform, continuous uniform distribution that we need to find. Now, probability of x less than 0, what it is? Minus infinity to 0. But we know right in this particular, in this particular case, we have our distributions defined between 0 to minus 1 to 3. So obviously we need to find it from minus 1 to 0, and we just integrate it, simple integration, and in this particular thing is 1 by 4. So this is how you deal with this particular uniform distribution. But obviously, we will see a word problem because in CMI, obviously, I just saw a similar word problem that I'm just going to solve. But I think this part is clear with you all. If you just have any confusion or if it's clear, just let me know. Is it clear? Now, so let's just discuss some word problem, and these word problems are something that is of our interest because these type of word problems is there in the CMI paper. So, thing is that there is subway train on certain line. So there is a certain line, and there is subway train. Uh, okay, just give me 1 minute. Please speak if you can hear me. I think my voice is audible, right? Okay, so I think if you don't have any problem, then just we move to this particular part. And at this place, we can see that this thing subway train example, and let's see what is it. Okay, so it's saying that on there is a line, there is a subway train, and on every half hour between midnight and 6 in the morning. So between 12 to 6, it's a train between every half hour. What is the probability that a man entering the station at a random time? So let's say a particular man enter a station at a random time between 12 to 6. during this period we'll have to wait at least 20 minutes. So the thing is that we have to find the probability that if a man enters the station at a random time, then at this point of time he will have to wait for at least 20 minutes to catch a train. Okay, so let's see how we can do this using the uniform distribution. So let the random variable x denote the waiting time. Okay, so like this particular x is the waiting time for the next train. So let's say maybe train would have left at what you can say, means 0 to 30 interval of period, 0 to 30-minute interval period. Maybe the train had left at 2 minutes. Okay, then the x would be 28 because you have to wait for next 28 minutes to get the next train. So that's this is the random variable x. Okay, it's a denote the waiting time in minute for the next train. Okay, for the next train. Under the assumptions that a man arrives at a station at a random, x will follow 0 to 30, because you know that for we are going to wait at least 0 and at most 30 minutes to get a train. This is a clear because the train running schedule is between every half an hour. Okay, so this particular thing, uniform distributions can be written as a this particular way. Okay, this is just a simple definition of random uniform distribution. Now we need to find a probability that he has to wait at least 20 minutes. Okay, so let's say the man would have arrived at this particular point. Okay, means what you can say. Let's say this is 0 and this is 30. Okay, and let's say man would have arrived at this particular point. Then the thing is that what is the probability that he had to wait for more than 20 minutes. So it means that the train is going to come after the 20 minutes. Okay, because x is the waiting, x is the time for when the next train will come. So it's asking about the person has to wait. The person has to wait at least 20 minutes. At least 20 minutes. He will wait 20 minutes or more than 20 minutes. Okay, so at that particular time we have to find a probability that this particular thing or this particular train is going to come after 20 minutes. Means this waiting time should be greater than equal to 20. Okay, so because obviously he would either have to wait 20 minutes or more, because it's asking about the at least 20 minutes. So in this case we just transfer this thing into the simple probability. It is probability of x greater than equal to 20. Simple thing, just do the calculation from 20 to 30, which is equal to 20 to 30, and then you have to just write the 1 by 30 dx. Okay, just do the simple integral and I will get your answer. So this is how a word problem will be. Like something is something will be there, and it will just like how do you decide it if it's a uniform distribution or not. So in that case, just you have to see like like something like this will be given key between a certain period. Whatever the certain period, maybe 0 to 30 or 0 to 40 or maybe 60 to 60 or 30 to 60. It between certain period, certain interval, certain anything, that overall thing will be the same. Okay, so that's how we will decide the this particular uniform distributions. So do you have any confusion understanding this word problem? Anyone? Okay, so simply just if you want to conclude the uniform distribution, the overall the distribution, the probability is going to be constant in over entire the range. If we just plot the probability, we'll get this particular rectangular graph. Mean is the this particular formula, variance is this, MGF is this, and in this particular thing maybe sometime mean given, variance given, or sometime homogeneity function given, or sometime entire distribution is given. But obviously sometimes this kind of word problem can be there, according to which you have to form it into, convert it into the uniform distribution, and then you can just calculate whatever you want. So after the uniform distribution, so we have some other type of distribution also. Obviously, you can do some other questions, but like more or less some questions will be like this only. Whether you have to given something like this, or like directly something is given, A or B is directly given. You need to find probability at x greater than one, or maybe x probability of x something between two particular thing, and you know that how to do particular this type of thing. Just do the integral between uh, those particular limit. Okay, or maybe sometimes the questions will be like this word problem. Okay, so these two types of questions are popular among the uniform distributions in the paper also and in the general also, because there are a lot of theory involved in the uniform distribution also, but obviously that's not of our interest. Okay, so if it's clear, then just discuss about the popular distributions that is we have, and this is the normal distribution, and we'll just see what is the normal distribution in very detail. So random variable x, like I will just discuss a lot of theory related to the normal distribution, and then we'll move to the problem, because like you have to understand the theory very clearly to get a good understanding of the normal distribution. So obviously you have to do this part. Okay, So just stick with me. We'll discuss a lot of theory, then we'll move to some questions. Obviously, some questions from the paper also. So random variable x is said to have a normal distribution with parameter mu and sigma square. So like in the normal distribution, specifically defined our parameter mu and sigma square in all its distribution too. But this mu is called the mean, okay, and the sigma square is called variance of the distribution. So these things we know in prior to define this distribution. It's not like we'll get the distribution and then you'll find the mean and then it's come to mu. We know that the particular normal distribution has the mean mu and variance sigma square. Then its particular distribution is given by this particular thing is written like this way. We are trying to find this particular distribution of x with parameter mu and sigma square. So this is a typical format of any continuous distribution. But in the normal distribution, we typically write either you can write as fx or you can write as this particular thing also x semicolon mu comma sigma. It tells that this particular mu and sigma are the two parameters of this particular random variable x. Okay, so it is 1 by sigma under root 2 pi. This is sigma, this is not 6. This is sigma under root 2 pi. And then e to the power minus x minus mu ka whole square upon 2 sigma square. So this particular thing, if like just write, this is sigma under root 2 pi. Okay. And this particular thing is e to the power minus x minus mu ka whole square upon 2 sigma square. Okay, this particular thing is there. So this thing is called normal distributions and with mean mu and standard the variance sigma square. Okay, this particular thing is called normal distribution. And in the normal distribution, we have some distributions also like x can be minus infinity to infinity. So it's defined over the whole range. Mu can be also like any value minus infinity to infinity, and sigma is should be greater than zero because obviously it's a variant. This is a standard deviation. So this particular format is there. Ki if you are having normal distribution, its PDF is going to be or probability density function is going to be 1 upon sigma under root 2 pi. So like you can just ask where this probability density function comes from. So it's not like that. This particular normal distribution is defined like this, and the application of normal distribution is very wide, not from only the statistics also, but in chemistry, physics, everything else like anything you just study, just demography also. So there's a lot of application of normal distribution, and this is most popular distribution in the statistics. And you eventually find that key when you will learn the regression later, regression analysis, you find that key one of the basic assumptions of the regression is about the normality. So normality or normal distributions is going to be at a lot of places when you are going to learn data science and other thing also. Simply the probability density function is 1 by sigma under root 2 pi e to the power x minus mu ka whole square upon 2 sigma square. Okay, so this is the particularly the normal standard normal distribution. Sorry, normal distribution with mean mu and sigma square. So just now let's see some of the properties of this particular distribution, some of the important point related to this distribution. So random variable x with mean mu and sigma square is actually represented by this particular thing, normal, and then you write the mu, mean, and then the sigma square. Okay, this is the particular two parameters. So the distribution also, and this is the mean and variance also. So we represent any normal distribution by this particular notation. Now, at this point of time, consider something called z, which is equal to x minus mu upon sigma. So let's say we are denoting this particular quantity, whatever it is going to be, x minus mu upon sigma by z. So this is not 6, this is sigma. So whatever this x minus mu upon sigma, this is represented by z. So you can just see that this particular thing is a standard normal distribution with mean 0 and variance 1. Okay, so you can just see that what does the particular thing means. So it means that like there is something called normal distribution and there is something called standard normal distribution. Okay, standard normal distribution. So if you just convert your random variable x into something like this particular thing will be converted into a standard normal distribution. So there is normal distribution, there is standard normal distribution. So standard normal distribution has mean 0 and variance 1 or standard deviation 1. Okay. But normal distribution has actually have some mean mu, it will be some number, and variance will be sigma square, it will also be a some number. So this is the particular difference between a normal distribution and standard normal distribution. And to convert any normal distribution into a standard normal distribution, we have to just do this particular transformation. Just change x as particular z is equal to x minus mu upon sigma. So whatever the mean is, just subtract it from the x, and whatever the sigma is, just divide it by the sigma, and you will get this particular thing as standard normal distribution. So we will see like what is the probability density function of standard normal distribution. But first of all, a standard normal distribution had have mean 0 and a standard deviation or variance 1, and this particular thing is represented by this way, normal 0 1. Okay, so whenever you encounter this particular thing, you have to understand that this particular thing is the standard normal distribution. and actually it's come from the normal distribution. And how it comes from normal distribution? Just the thing is that you have to convert it x as x minus mu upon sigma, and then you'll get the standard normal distribution. So its mean will be zero, and then and standard deviation will be sigma. Okay, so this probability density function of standard normal distribution is given by one upon, obviously like this in this particular thing, you just replace sigma by one, and then x minus mu upon sigma by z. So you can see that in this particular thing, if you just represent by z, it will be z square by 2, and this will be 1 upon root 2 pi. So the particularly probability density function of any standard normal distribution is 1 by under root 2 pi e to the power minus z square by 2. Obviously, this is the simple thing, just you have done the same thing, like e to the power minus x minus mu upon sigma ka whole square. This particular thing is being replaced by z, and 1 by 2 is obviously at this place. Okay, just you can see this here. Same thing is there, same thing, nothing I'm doing fancy. So, any confusion regarding understanding how this standard normal distribution is coming from? Any confusion, just let me know. Guys, anything you have, you want to, any confusion you have, or is it clear? Okay, so the questions that you'll be solving now, or maybe the later, actually it will be based on the standard normal distribution, because like scientists from the very long time, what they did, they actually studied the standard normal distributions very much, and they have tabulated a format of like at this particular thing, what is going to be the value of standard normal distribution. So we will be converting every problem into a means every problem of normal distribution into a standard normal distribution by simply making this particular transformation x minus mu upon sigma. Okay, and then we will have some standard value from the standard table. In general, we have a very long table of the standard normal distribution. So that particular table I can't give you here. But whenever in exam you will be asked standard normal distribution questions, a particular value will be given. So like we will talk about what is the particular value we are talking about. So we'll just see particular thing. Okay, just say that we'll see think that standard normal distribution is of our interest, and whenever we will study the normal distribution, we will convert that problem into a standard normal distribution. So this particular thing is its probability density function. Obviously, z will be minus infinity to infinity, because when you convert this particular thing, x minus mu upon sigma. So obviously, this particular thing is between the both the range. So this particular thing, x minus mu upon sigma, will be from minus infinity to infinity, and this particular thing is not going to change. Okay, so every probability density function, we talk about the cumulative density function. So till now, cumulative density function or CDF was not of our interest for other distribution, but for a normal distribution, this particular cumulative density function is of our interest, and this is the main thing that we have. Okay, so what this particular thing is means, like normal distribution, standard normal distribution is represented by this theta or this phi. Okay, so this is called a small phi, and this is something called capital letter phi. So capital letter phi is like this. Okay, so this particular symbol is called capital letter phi. This is called a small phi. So these are the symbols, and obviously the same thing is both are the phi, but this is the small phi. We have a small and capital letter in the English also, so that this is the same like that. So capital letter phi actually represents the distribution function or cumulative distribution function. Okay, so what this particular cumulative distributive function is, we know that any particular PDF fx, the cumulative density function, cumulative distribution function is defined by probability of x less than equal to x, or maybe equal to minus infinity to x fx dx. Okay, so same thing we have also probability of z less than equal to z, and from minus infinity to z of phi x dx. Okay, so this particular thing is called as standard. Sorry, the distribution function of your standard normal distribution. And how it is going to be, just replace this particular thing by this, and we have 1 by root 2 pi minus infinity to z e to the power minus x square by 2. So this is just probability of z less than equal to z. So let's say you are trying to find probability of z less than equal to 2. So what this particular thing is, 1 by root 2 pi. Okay, and then minus infinity to 2, z is equal to 2, and e to the power minus x square by 2 dx. Okay, so obviously you don't need to calculate these integrals. A value will be given to you, or obviously every time you just find any questions that require you to calculate this particular probability of z less than equal to 2, or probability of z less than equal to 3, or 0, or 1, anything, your particular value will be given. So that is always there. In some book you can't find values, and the particular book will calculate the answer directly, but the thing is that in the examinations the value will be always be given, and just you can use those values to calculate the answer. So just the simple thing is that till now we have discussed like the normal distributions, its product density function, and its this cumulative density function. So cumulative distribution function is actually be used for the our problem purpose. And just like just if you see some particular thing, so this phi z, obviously this phi z, you can just represent this particular phi 2. What is phi 2 or maybe phi 3? What is phi 3? So phi 3 is, like phi 3 is all the means of probability till minus infinity to 3. Okay, so we will see some particular graph of the this particular normal distribution, and then we'll understand that how this particular probability means. But till now, do you have any confusion understanding this particular probability function or corresponding distribution function, or like how these things are coming? So just till now, just remember three things. Normal distribution is mu sigma square. Standard normal distribution is mu, sorry, 0 comma 1, because mean is 0 and standard deviation 1. And this particular PDF is given by this particular thing, the normal distribution. The next thing is that this particular phi capital phi z is actually the corresponding distribution function, and is equal to probability of z less than equal to z. That means from minus infinity till z, whatever the probability is, it's being added everything. So this part, do you have any confusion regarding this part, or is it clear? Okay, so we will discuss this particular example later, but just for first, let's just discuss some more properties, because those things will be eventually be there. But like this particular thing is that, let's say x is normal distributed random variable with mean of x is 12 and standard deviation is 4. So mean means mu is equal to 12, and standard deviation means sigma is equal to 4. Okay, so in that particular case, like whenever you want to find probability of x greater than equal to 20, so this thing, obviously, whatever is the probability that we need to find in the case of normal distribution, we will convert those things into a standard normal distribution. Okay, so obviously, these things to find this probability will require some more properties of normal distribution, but we will see those things. But thing is that whenever you want to find this particular types of probability, just you need to convert those things into a standard normal distribution. So how do you convert those things? Simply x minus mu upon sigma, because this thing is going to be z. So this same thing we have done. X is equal to, let's say, 20, because then we want to find x greater than or equal to 20. So z is equal to 20 minus mu, which is 12, by sigma, which is 4, which is equal to 2. So probability of x greater than or equal to 20 simply translate into probability of z greater than or equal to 2. Now here z is equal to mean 0 and standard deviation 1. And like this particular thing we will find using the number that has been given to us by the examiner. Okay, so these things will be given to you in the exam, but obviously we need to read some properties. Based on that, we will just see how to do those things. So anything, just you want to find this probability, we need to convert it into this particular thing into z, and this particular thing into z also, and then we will just translate the probability into a standard normal distribution. Just see, we'll just get back to those things. Okay, so first thing is that, like the graph of this particular random standard normal distribution is the bell-shaped curve. What do you mean bell-shaped curve? So like it will be a complete symmetrical bell-shaped curve, complete symmetrical. Okay, so like it may not looks to complete symmetrical to you, but it is complete symmetrical. I just my drawing is so bad, but like it's a complete symmetrical graph. Okay, so this particular graph is the graph of standard normal distribution, and the thing is that it has some property associated with that. So like this particular thing, the topmost thing is the actually mean of this particular mean of this particular random or normal distribution. Mean, if it's a normal distribution, then it's mean, median, and mode. Mean, median, mode actually coincide at the same place. Like later you will learn about something called left tail distribution, left tail distribution, or right tail distribution, or skewed distribution, skewness, kurtosis. But obviously, the thing is that if you're talking about a normal distribution, a perfect normal distribution, it will have a bell-shaped curve, and the thing is that it will have the mean, median, mode. Everything will coincide at a single point, and it's the topmost point, and this particular corresponding value of x is the mean and median and mode. Everything coincides at a single point. Okay. Now, talking about this particular thing, the next thing is that, like we know that capital phi z, capital phi z. What is capital phi z? Capital phi z is equal to probability of capital Z less than equal to small z. Okay, so let's say we're talking about phi 2, or phi 3. So phi 3 means, or maybe phi 3 means this particular thing. Let's say this is equal to a standard normal distribution. Okay, a standard normal distribution it is, and we know that a standard normal distribution mean is equal to zero. So a standard normal distribution, this point, this particular big line, this particular peak is at x is equal to zero. Okay, so phi 3 means it's going to be something like here. Phi minus 3 means it's going to be something like here. So this particular thing you can just visualize by the graph. So here is a theorem. The theorem is that phi of minus z is equal to 1 minus phi z. So what particular thing means? Let's say we want to calculate phi of minus 3. So phi of minus 3 means every value that you want to calculate, that is probability of capital Z less than or equal to minus 3. So means all this particular area is the your required thing for phi of minus 3. Okay, capital phi of minus 3, and I am telling that this particular thing is going to be 1 minus phi z. Okay, so what is this 1 minus phi z? So 1 is the reason of the whole probability. If you just add over, find the area entire the it means below this particular curve, it's going to be 1, because obviously inside means below the probability density function everything is means if you just add all the probability, it's going to be 1. Now, one means the whole region, and among the one you have to just subtract this particular thing phi z. Phi z means obviously whatever the z is, it's this positive form. So phi minus 3 is there, then phi z is phi 3. And what is phi 3? Capital phi 3. Capital phi 3 is all the region. So let's just take this highlighter. So the phi 3 is all the region. This is 3. So the phi 3 is all this particular region. Okay, all this particular region. Okay, so this is the phi 3. So obviously, like if you just we know that this particular curve is the symmetrical curve, and if you just subtract, like this particular region, this particular region, this particular region, it's same as this particular region, because both curves are symmetrical. The first thing is that the normal distribution curve is symmetrical. As told you, is the bell-shaped curve, complete symmetrical about this particular mean. Okay, so this thing is the bell-shaped curve, and this is a complete symmetrical. So whatever you are seeing, the area here minus 3 say hatke, then that area will be the same after the minus 3, plus 3 also. So those particular two area will be same. So obviously, if you just subtract this particular the yellow region from the one, you will get this particular area, and we know that this particular area is same as this particular area. So this particular theorem can be understood in this way. Okay, whatever the 5 minus z you want to calculate, it will be 1 minus phi z. So like it may be like phi of 0. Okay, so phi of 0, obviously we know that with this particular standard normal distribution, phi of 0 is the midline, and you can say it's a mean, it's a median, it's a mode. So obviously this particular thing is whatever the area here in the left side, it will be 1 by 2. This probability will be 1 by 2, and whatever the area it's going to be this particular side, it will be 1 by 2. Okay, so because phi 0 is equal to going to be 0.5, because 0 is the mean for the standard normal distribution. So guys, do you have any confusion or any questions understanding this particular thing, or do you have any question? Anyone, do you have any questions, or is it clear? Okay, so simple thing is that just to understand this particular formula, which is obviously the this thing that minus 5 of minus is equal to 1 minus 5 z, and obviously this is true because obviously this is a symmetrical curve. If a minus 3, so whatever the reason 5 of minus 3 means from minus infinity to till this particular region. Okay, so this particular thing is, I know, like this particular x-axis, so this is the x-axis. So if we just familiar about the math, so this is called asymptote. Like this particular curve will never touch the x-axis, but it seems like it will touch, but it will never touch the x-axis actually. So this is called asymptote of this particular curve. Okay, so the thing is that whatever the minus infinity to minus 3, this area will be given. The same area is the from 3 to infinity. So obviously, if you want to find this way, you can just translate it into this way also, which is over the whole one region. Just calculate this arrow shaded region, and you will find a particular probability. So this particular thing is there. Now the second thing is that if you are having a normal distribution mu sigma square, then I told you every probability that you are going to find, you have to translate that probability into standard normal distribution. So like this particular thing will translate it into say this way. So this thing we can do it this way, because obviously we just subtracted minus mu from everywhere and just divided by sigma. So the equality sign is going to be remain same. Now, 1 minute. Okay, so now at this point we will have this particular thing, okay, this particular thing, and this particular thing, and this particular thing. So this is obviously z, okay, this is the z, and if this is a z, okay, so we can represent it, we are going to find probability that a minus mu upon sigma greater than z and less than equal to b minus mu upon sigma. Okay, and this point of time, just we know that key obviously obviously let's say this particular thing is the b minus mu upon sigma. So let's say b minus sigma is some point here, and okay, a minus sigma is some point here. So if you want to find a probability between these particular two things, then what you need to do, just get whatever the entire probability for this region, okay, and just subtract this particular probability, which is x minus a upon sigma. So that's what we are going to do. Capital phi, which is a standard distribution function, distribution function of a standard normal distribution, minus phi a minus mu upon sigma. So this particular thing is going to be there. Okay, so just like the same way I discussed, if you just want to find 0 between x greater than 12, so what you need to do, like we need to do 0 minus whatever the mu is 12 upon 4, which is equal to minus 3. And this particular thing is 12 minus 12 upon 4, which is 0. So this particular thing will translate into probability of minus 3 greater than equal to z greater than equal to 0. Okay, greater than equal to 0. So this particular thing is going to change into this particular way. Okay, and now what you need to do, you need to find this particular thing minus 3 to 0. So let's say this is minus 3 and this is particular 0. So you need to find this particular probability. So how we are going to find it? Obviously, you know that this particular probability is going to translate into probability of uh, means phi of 0 minus phi of minus 3. So phi of 0 is 0.5. Obviously, we know that particular thing, and phi of minus 3 will be given to you. And using those particular value, we'll just find this particular thing. Okay. So, do you have any confusion understanding like how this particular normal distribution is getting translated into a standard normal distribution? Okay, so we know that this particular thing. Just I want to just explain. Let's say we have this particular distribution. Then like this particular spread, like how this curve is going to be spread, is actually it's talk it's talk in the term of sigma. So sigma is the variance. Obviously, it's talk about the whatever is going to be the this particular spread of the curve. Okay, so those things will not be as important, but obviously you need to understand like how what is the mu, what is the sigma, and what is the significance. Okay, so the next thing is like a standard normal distributions as a limiting form binomial distribution. But I think before that we can see some example. Okay. Okay, like whatever I'm talking about right now, it actually will may seems like it's a lot of theory, but obviously in the normal distributions you have to know all those things, and based on all those things there will be questions. And once you understand all those things, questions are actually not too hard. So, like normal distribution as a limiting form binomial distribution. So, particularly using this particular theorem, questions has been there in the I think 2019 paper. So, what it does say, let's say we have two following conditions. We have two following assumptions, two following conditions. The condition is that let's say n is the number of trials and is indefinitely large. So it's a very very large. Let's say n tend to infinity, and some very large number. And p or q are not very small. Which is not like that p is very small. Like in the case of like Poisson distribution, we used to talk like n is the very large and p and q are actually very small. But thing is not like that in the normal approximation of binomial distribution. So n is very large and p is some value but not too small. So let's say if x follow binomial distribution n comma p, in that case like its mean will be np and its variance will be npq. So normal distribution in the binomial distribution, you have mean is equal to np and variance is equal to npq. So like consider this particular random variable z is equal to x minus expectation of x upon under root variance of x. Like this particular thing, z is equal to x minus mu upon sigma. Obviously, mu is the mean and sigma is the standard deviation, which is the root of the variance. Okay. So this particular thing you have to consider. Replace mean by the binomial distribution mean (np) and replace this sigma by the binomial distribution variance, which is (npq). And this particular thing x minus np upon root npq. This particular thing will now follow a standard normal distribution, which is normal 0, comma 1. So this is the normal approximation of binomial distribution. Simple thing is that if n is very large and you need to solve any particular type of questions, then just don't solve that particular questions by binomial distribution. Just solve that particular questions by this particular thing. Uh, a standard normal distribution. So we will see some questions from the paper, obviously questions of this type, because I did not find any questions of this type in any book, but obviously in the paper using this particular theorem there has been questions there. So we'll see that question. Simple thing, if you have just binomial distribution where n is large and p and q are not very small, so if p and q are very small, then you have to use Poisson distribution. But if in p and q are not very small, then in that case you have to use the normal approximation of binomial distribution, which is just consider this particular thing, and now this particular thing will follow normal 0, comma 1. Okay. So like overall, just let's just see some same properties also, like the we discussed with. If n is the mu comma sigma square, this particular probability, then curve is the bell shape. Obviously, we see that this is the bell shaped curve. Okay, symmetrical about x is equal to mu. We also saw that, and mean median mode of distribution coincide. Obviously, we saw that mean median mode coincide at the same point. This particular line. As x increases, fx decreases. So you can see that this particular point means as x increases, this particular fx decreases after some point. So this particular point is where this particular probability is the maximum. Okay, and that probability at maximum at x is equal to mu is given by this particular formula, 1 by sigma into 2 pi. So obviously, when you just put mu in the original formula, you will get it 1 equal to sigma 1 upon sigma into 2 pi. This is the maximum probability at x is equal to mu. So this formula you have to remember. Now there is something called area property. Okay, so area property means that like if this is a normal distribution, standard normal distribution. In that case, let's say this is the mean. Okay, this is the mu. Now it says that 68% of observation, 68% of the observation actually lies between mu minus sigma and mu plus sigma. So let's say mu is equal to let's say 4 and sigma is equal to 1. Okay, let's assume this particular thing. Then what is mu minus sigma? Mu minus sigma is 3 and mu plus sigma is 5. Okay, so it means that 68% of observation in your distribution actually lies between these uh, two particular values, 3 and 5. So this particular rule of approximation is very much helpful, because like sometimes you may be asked these type of questions in MCQ, and sometimes in the problem also, and the same thing will be given, or some number will be given, like mu and let's say I just give you some mean mu and sigma 1, and just ascertain you which the following options are correct, and something like 3 greater than x less than 5 is equal to 0.68. So you may assume that okay, how this particular thing is going to be there from the just mu4 and sigma 1. So this is going to be this particular area property, and there are three area property, which is roughly that your 68% observation roughly lies between mu minus sigma and mu plus sigma. Your 95% observation means obviously probability is 0.95. 95% observations, 95% of your data lie between mu minus 2 sigma and mu plus 2 sigma, and your 99.73% of observations lies between mu minus 3 sigma and mu plus 3 sigma. So whenever some mu and sigma is given and some probability of this kind, this is being talked about, just check whether this actually satisfies the area property. In that case, you can easily just find this particular property, particular probability. Okay, it may happen that let's say x is equal to mu is equal to 4 and sigma is equal to 1. And I'm telling you, okay, just find a probability between what is 4 minus 3 sigma 1 and x less than 4 plus 3 sigma 7. Okay, find this particular probability. So obviously, let's say at that particular point, let's say this particular phi is not given, phi 1 and phi 7 is not given, then how we are going to do that? So in that particular case, you have to apply your mind whether this particular thing satisfy area property or not. Obviously, it's satisfying because you can see that mu 4 and sigma. If you just find this particular thing, you can get it. Okay, this is the mu minus 3 sigma, and this is mu plus 3 sigma. So this probability must be 0.9973. So this is how we actually utilize area property to solve the particular question. Guys, is it clear? So whatever the formula that I'm talking about, it will be actually very much helpful. And whatever I could find, I have just consolidated everything in this particular PDF. And using this particular thing, I don't think you'll miss any questions in the paper also, and in the obviously in the general exam also. So next thing is a moment density function. So moment density function normal distribution is given by e to the power mu t plus sigma square t square by 2. So if we just see somewhere in the life that a particular distribution has some particular moment density function like this, just assume that just it's 100% sure that a particular distribution is normal distribution, and it has this particular mean mu as mu and this particular sigma square as the variance. Okay, so this particular thing is clear. So this is the MG of normal distribution, and there is something called additive property. So additive property means, like if you have some xi n number of random variables, then and those are independent normal distributions, then if you just find a distribution of sigma I from 1 to n ai xi. Ai xi means, it means that a1 x1 plus a2 x2 plus dot dot plus a and xn. So if you try to find a distribution of this particular thing, and if all the xi's are the independent normal variates, in that particular case, your distribution, your resultant distribution, this particular summation distribution is also going to be a normal distribution. And at that particular place, your mean will be summation of all those ai mu I, and your standard deviation will be this particular thing. Okay. So sigma ai square and sigma ai square. So this particular thing is the additive property of independent normal distribution. Normal distribution. Okay. So this thing I don't think will be useful for you right now, but obviously this is a property that you have to study. So just let's see some questions from the thing that I was talking about. So let's say ki, x is given a normal distribution with mean 30 and a standard deviation 5. So you need to find 26. This x, find the probabilities that this probability of 26 x greater than or equal to 26 and less than or equal to 40. Okay, so you need to find this particular probability. So obviously I told you this particular thing should be translated into a standard normal distribution, because your table, your questions will be given some particular values in that form. Okay, so this means that x is equal to 26. So we'll convert it into z. So z is equal to x minus mu 1 sigma. So 26 minus mu, which is 30, and sigma 5. So this is 0 minus 0.8. And same thing with the x is equal to 40 also. So that one thing is 40 minus 30 upon 5, which is 2. So this particular thing is being translated into this minus 0.8 to 2. Okay, so minus 0.8 is somewhere and 2 is where. So obviously, like I have done some calculation, but this is what you can just break into simple part also. But thing is that your values of this particular thing will be given. So maybe phi 2 will be given, phi minus 0.8, or maybe phi 0.8 is given. So this particular thing will be given to you, and according to that, you have to find the particular values. So I have just done some calculation, but this does not mean that you have to follow the same thing. If just arrive at this particular point, and then you can utilize the whatever the values has been given for these two things, or the similar things in the questions, and then you can write the answer. So just like I just utilize something like you can break this part also. So minus 8 to 2. So I just want to say that you can break it into two part, minus 8 to 0 and 0 to 2. So just I have just break it into two part, minus 8 to 0 and 0 to 2. So obviously this particular thing, whatever this 0 to 2 is there, this particular probability, actually these things will be given in the particular questions. Okay, so don't worry about this thing, how this particular thing is going to be that, how this particular thing is going to be that, how this is 0.4472. This is will be given in the question, but just think that this particular thing can be translated into this way by breaking the part. Obviously, minus 8 to 0. This particular thing can be converted into 0 to 0.8 also, 0.0.8, something like that. So this thing is the same thing. So obviously, all the conversion you can do, but whatever the value that you are putting here, this particular value, this particular value, this particular value, this will be given in the question. So don't worry about it. Just see how you can break this part to just bring it into a simple form, and then utilize the that is value that is given. Okay, so let's say we want to find probability of x mod of x minus 30 greater than 5. So obviously this particular thing is translated into 1 minus probability of mod x minus 30 less than equal to 5. Obviously, why we do that? Because this thing is easy to break down. Okay, so how do you break down this particular thing? This particular thing is break down by minus plus minus, like obviously this particular thing is there na, if mod x is less than equal to a, then x is equal to minus a less than equal to a. So this particular thing is there. So if mod x less than equal to a, then x is actually between minus a to a. So this particular thing is x minus 30 between minus 5 to 5, because this mod is will be break it down to this part. And at this point of time, just add 30 both the sides. So x greater than equal to 25 and less than equal to 25. Obviously, at this point of time, you need to find, means if you want to find this, you translate into 1 minus something like this, and this is getting translated into this way. Now we have to convert it into the z format, means the standard normal distribution format. So obviously minus the mean and divide by the sigma. So minus 30 divided by 5 that you have given in the question, and that particular thing is converted to minus 1 to 1 z. Obviously, minus 1 to 1 z means, like simple thing. It's like you can see that z is equal to 0 here, and minus 1 to 0 and 0 to 1. So both the area will be same, because it's a symmetrical distribution. So obviously you can write it two times area between 0 to z, 0 to 1, and this particular thing will be given to you in the question, and you can find this particular probability. Now if you just do 1 minus 0.6826, you will get this required probability. So guys, do you have any confusion understanding this particular question? or any something like that? Okay, so we have our questions, some more questions. This is particular questions from the CMI paper. So we may discuss those things, and obviously we have some more distribution also like gamma and beta. So I think that's it for today. Obviously, we need one more class from today tomorrow because obviously we have a 9 o'clock, and we'll discuss these things tomorrow. And after this, I think after means this is the particular questions of CMI paper, and like this particular thing is given, everything will be given. Like it's saying that you have a Gaussian standard distribution, mean zero, standard deviation one, and this particular thing is given, which is obviously I told them this is particular phi a or phi z. Okay, so this particular thing is given. It's given in the question, but I'm not writing it by myself. There are a lot of values given also. So I told you there are a lot of values given in the question also. There are a lot of values given in to you also. And there's also some note given that x is equal to if z is the standard normal distribution 0 comma 1, then x which is mu plus sigma z actually follow Gaussian distribution with mean mu and standard deviation sigma. This is the same thing. And now it says that ki in a in an exam, okay, the score of the student actually follow a Gaussian distribution with mean mu and standard deviation sigma. A candidate fails means in the exam if a candidate fails, he she get less than 35%. So let's say the student get marks less than 35%, he will be failed. Okay, and if he has scored more than 80%, he passed with a distinction. Okay, exam is taken by the group of 225 student, then this particular result is given. Ki, some pass with distinction, only 2% of the student pass with distinction, and only 82% of the student actually has passed without distinction. And like 16% of student, if you just add 2 and minus 100, 16% of student actually failed the exam. So this particular thing is given. There is also a different fact given that if x follow normal distribution, then x bar, the mean of all those normal distribution, actually follow normal distribution with mean mu and standard deviation sigma upon root n. So these are all the facts given in the question itself. I'm not just making up with you. It's everything given in the questions. And now we need to find this particular thing, which of the following is correct. So like in the CMI paper, when let's say there is some another kind of distribution that you don't know, let's say that is particularly triangular distribution, okay, or maybe triangular distribution, you don't know, but whatever is required you to calculate in the questions, that will be given to you in the question itself. So I told them CMI don't want to evaluate you based on your knowledge. Okay, maybe sometimes you don't know something. If you just don't know Gaussian distribution also, you can solve this question, because whatever required to obviously calculate in the Gaussian distribution, you have given this particular thing. Okay, so this particular thing is there, and we have to utilize all those things to find which the following statement is true. Okay, so let's see how we can find this particular thing. Then we can just close the session. So obviously we have given a lot of things. So like at this point in time, we know that he only 16% of a student fail. We know this particular thing. We also know that only 2% of a student pass with distinction. Okay, we know this particular thing. So obviously, when a student will be checked, obviously a particularly if Ax is less than equal to 35, then that particular student is going to fail. And that particular thing is 0.16. We have given this thing, right? And we also showing that if probability of x greater than equal to 80, then that particular thing is going to be means he is getting passed with distinction, and that particular number of students is only 2%, so 0.02. So this particular thing we have given, and we can just understand by this particular percentage of student that is been given to us. Is it clear, like whether I'm getting this particular information? Guys, is it clear? Okay, so using this particular thing, we can see that in the question itself, we are when something given it, we need to find some mu, some sigma, and something called mu plus sigma. So obviously, if we just get mu and sigma, then we can find it which of the statements are correct. So probability of x less than equal to 35 means we have to convert it into the standard normal variant. So means 35 minus mu upon sigma, and that is going to be 0.16. So obviously, we have done the same thing. X less than equal to 35 means x okay, so x 35 minus mu upon sigma, which is and this particular probability is going to 0.6, because we have been given this particular thing. If 0. This particular 16% of a student actually failed the exam, obviously, and this 0.61 is the value of this 5 minus 1. How do you know that? We have been given this particular thing here. Okay. So I told you in the question itself, we have been given a lot of information, and you have to utilize your information to solve your particular question. So again, the second thing is that probability of x greater than or equal to 80. So you know that this the means the standard distribution actually don't evaluate this way. It is something like probability of x less than or equal to some number. So we just convert into this way. We do one minus. So we will convert it into x minus x. Probability of x less than or equal to 80, and this thing will be 0.98. Okay, because if we just do one minus here and one minus here also, this will be converted into probability of x less than or equal to 80, and this will be 0.98. Okay, so this particular thing is there. The probability of x less than or equal to 80 is equal to, obviously converted into z, 80 minus mu upon sigma, and obviously this is 0.98, and this particular thing is the value of phi 2. How do you know that? Obviously we have been given this particular thing in the question itself. If phi 2 is 0.98. Okay, now what do you do? We know that this particular thing is going to be minus 1, and this particular thing what is inside it is going to be 2, because both all the things are equal here. So just we have this particular thing and with this particular thing, we obviously do some calculation, solve those out, and we get that mu is equal to 50 and sigma is equal to 15. So at this particular point of time, you can say that this particular option D is correct. So obviously, if D is correct, C is not going to be correct. And mu minus sigma is 50, but mu plus 2 sigma, mu plus 2 sigma is not going to be 80. So this is not correct. And mu minus 2 sigma, this is not 16, so this is not going to be correct. So only option D is correct. Okay. So obviously, whatever the information is given in the questions, we have to utilize those information in a way we can solve the question. So I think this question is clear with you all. And if you have any questions, just let me know. Guys, is it clear? Okay. So I just advise you to just go and practice the question same way. Like, how do you think that? So I just written like only 16% of student fail, 1 and 2% student pass with distinction, and these information is getting being used here to find the probability. Okay, so option D is the correct. Now we have the next questions in the same part in the same CY paper. You had to find the probability that. So the question is like find the probability that the average marks actually does not exceed 48. Okay, so means that if average marks means like maybe I have to see the questions, but the question is something like okay, just let me just open the questions if I they will understand it better. Okay, so I think the screen is visible again, right? So let's see where the particular question is. Because like this particular question also of normal distribution. So this particular question is also of normal distribution. You can see that there are a lot of things given also. Okay, so there are a lot of things are given. Obviously, this all will be given to you. And told you this all will be given to you. Just don't worry about it. So you can this particular questions you can also try. And but the question that I was showing to you, actually it was different. So let me just find it question. Don't remember. Okay, okay. I think it should be yeah, yeah. It's here. Okay, so here is it. Okay, so the next thing is that you have to what which of the following is are correct, and which of the following is are correct means you have to find the probability average score of the means you have to find this particular thing, verify this particular thing is correct or not. So obviously you have to go step by step. So first statement is that probability that average score of the group 225% is less than 48 is 2%. So कह रहा है कि if you have 225%, then the average score is less than 48, its probability is less than 2%. So like if you just see here कि average score is represented by x bar, which is mean, and is less than equal to 48, this particular probability is greater than is equal to 0.02%. So we verify this particular thing. It's not like the truth. It's saying that if this statement is correct or not. So let's see if its statement is correct or not by finding the probability x bar less than or equal to 48. So how this do you find this particular thing? We know that obviously, where is my so we know that if x follow normal distribution, okay, mu comma sigma square, then this particular x bar is going to follow a normal distribution with mu, same mean will be there, and then sigma by root n. Okay, sigma by root n. How do you know this particular thing? You can just know, get it by the fact, and this particular fact is given in the questions. I'm not just making it up to you. So this particular thing is there, and sigma upon root n, what is it? So sigma is equal to 15, and root n is equal to 225 number of a student. So this is going to be 1. Okay, so x bar will follow normal distribution with mean 50. What is it? 50, yeah, and standard deviation 1. So just convert x bar into the same thing, the z particular z format. X bar minus 50 upon 1 and 48 minus 50 upon 2. So this is probability of z less than equal to minus 2, and it is given that probability of z less than equal to 2 is 0.98. So obviously probability z less than minus 2. I told you na, if probability of a is equal to 1 minus probability of minus a is equal to 1 minus probability of a. I told this particular thing. Okay. So this thing is going to be 1 minus 0.9, which is 0.02. It means that only 2% candidates are there. So this statement is correct. Okay. Similarly, you can check for B, C, D, and all the statement, and you find it only A and C statement are correct. So obviously, like these informations you have to utilize this way to solve a particular question. So I think it is clear to you all, and like, obviously you can go and watch the recording and see like how the things are happening. And if you have any questions, let me know. Otherwise, we will just end of the session.